you have to see that we can use like other software, we have to specify the units, but here it is already taken. So here it is showing the consistent unit. Whatever you want, you can use the SI unit, US unit, in foot or inch, mm. So I'm going for the unit. Okay. So whatever you design the model, according to that, you have to take the units. Okay. Now, okay. Now it is 0.35. Okay. Then I'm going for the thermal property, that is thermal conductivity. Thermal conductivity is 0.18. Okay, then specific heat. Okay, it is the constant pressure Cp, and the specific heat is 170. Okay, what are the properties we have assigned? It is seen here in the density, elastic, conductivity, hyperelastic. Okay, sorry, specific heat. Okay, then here. Okay, let's see here. It is acrylic plastic and the canes. Okay, we have designed. We have taken the two materials, so it is showing that two materials are in the material section. Okay, now we go for the section. So we have designed we have taken the materials, but that Abaqus software will not know how to which material is going to what section. So for that we will go for the sections. Okay. Here it is sections. Okay. So I am going for the section, that is sections. Suppose I am taking that PLA. Kind of for 3D printing we used this PLA software, that is polylactic acid. It is a thermoplastic material. Okay. Now I'm going to continue. Okay, that PLA is, which one is? PLA is acrylic plastic. Okay, then I'm going to okay. So for sections, it is coming under the PLA. Okay, then also we have to assign section is acrylic, that is silicon. Okay, so I'm going to again create. Here I am going to silicon. Okay, then it is continue. Okay, here silicon is this metal kilns. Okay, okay, here we have to see that in section PL and silicon in material this one. Okay, then we have to go for the section assignment. Okay, then we have to go for the section assignment. Here it is the section assignment. Okay. Okay, select the region. Here it is showing that select the region to be assigned a section. Okay, suppose I am going to assign this one. Okay, so this one is silicon. Okay, it will be inflated. Okay, then done. Here section is silicon. The material is GANs, and it is okay. Okay, done. That color is changed so that silicon is added to this one. Okay, then I am going to another that bottom layer, bottom first part. So create another one. I have to check. Okay, so this is done, and section is PLA, acrylic plastic. Okay, now the model is assigned to the material. Okay, now we have to go for the next. We have to go for the meshing. Why we are going for meshing? Because we have to change the infinite model to finite model. If you check the any software like console, if you have gone through the console or any software, then you have to do for the meshing, because we have to apply the pressure each and every point, so that we are going for the meshing. So we have to easily simulate the model. Okay, so I am going for the meshing part. So okay. Okay, now we have to go for the meshing part. Okay, here it is meshing part. Okay, so we are going to for the meshing for the both part, that uppermost and the lower part. Okay, so I am this one. We have to select the regions to be meshed to assign to mesh control. Okay, so we have to select. Okay, for pressing the shift key, we have to assign the both. Okay, then done. Okay, we have to go for the element shape hex dominated tetrahedral wedge. I am going for the tetrahedral shape, and all the default algorithm will be as usual. Okay, no need to change anywhere. Okay, then we have to put OK. Okay, then the select the entity division. It is already selected, so no need to select. It is simply done. Okay, next we have to check the meshing, that the element in which cell, which size. Okay, so far we have to seed part. Okay, here it is our global size. I am taking that 3. Okay, and this is apply, so that it will be applied on every surface. Then apply OK. So we have already applied the what is the element size, element global element size. So I am going to see, for that purpose I am going to click on OK to mesh part. Yes, it will take some time. Okay. Let's see how our model looks like after meshing. Okay, the model looks like this one. Okay, next. Then I am going for the mesh. It is the most important thing. I am going for the mesh, and it is the element type. Okay, so I am clicking this one and also this one. Okay, then done. Okay, then this is the standard. We have taken the standard. Okay, it is coming under the 3D stress. In the geometric order, we can take linear or quadratic, but this design is quite complex. So we have taken that quadratic, and this is the tetrahedral we have previously defined. So we are clicking the hybrid formulation. So this is, I think it is kind of default, but if you change the this one, you have to check for the specified directory. That is hex, what we have to select wedge. I am going for tetrahedral, so I am going for the these steps. Okay, then I am clicking OK. Okay, select the agent class. Okay, so this is the meshing property. So meshing is quite important for the simulation purpose. So for doing the meshing, we have to check for these steps what we have taken. First, we have to click the which part we have to taken the mesh part. Then in which portion, what is the element size. Then we have to see. Then we have to click the what shape it will come. Okay. Then we have to go for the meshing. Okay, then I am going for the, finally our model is created, but now we have to give the pressure so that it will inflect, and I am showing that this will inflate like this one. Okay, here I am previously designed and it will looks like this one. Here I am given the more pressure, but it will take some time to looks like this one. Okay, so I am designing this one. Let's see. Okay, where I am going to then assign the steps. That is, here the steps is kind of force. That is, we have to put the gravitational force or pressure energy, what kind of force we want, we can use here. Okay, so for that same step we have to double click or right click and create. Okay, now I am going to first put the gravitational, because the fixed portions, that the four boundaries and the bottom part will be fixed and the upper part will be only inflated. So for that I am putting that gravitational force. So gravitational. Okay, then it is insert new, that initial step is already existed, and I am not going to edit the initial part. It is as default. For that I am going to add another step. Okay, no need to worry about the initial step, it is as usual. So we have to go for the static general, because for the fluidic property we have to go for the fluid property, that is CFD, computational fluid dynamics. So we have not go for the CFD, so I am going for the static and general, it is continuous. Okay, then here it comes. But in this simulation, we are going for the nonlinear geometry, because it is nonlinear. So I am clicking the nonlinear geometry. Okay, and the incrementation, that incrementation side should be small, as much as possible as small. So I am clicking at 0.1. Okay, increment size 0.1. So in all the properties will be same. So I am clicking that on OK. Okay, here the gravitational force is created. Okay, for the gravitational force is created. So in that we have to apply the boundary condition, also the load, because boundary conditions are this one, that we have to put the boundary condition in the boundary and the bottommost layer. Okay, so I am clicking the boundary conditions. Here the boundary condition is we have to click the fixed end. The kind of we have to fix the. So I'm going for the naming as your wish, as your wish. You have to. I am going to fixed end. Okay, fixed end. Okay, then it is gravitational. Okay, it is mechanical and the symmetry. Okay, then we have to go for the continue. Then select the regions for the boundary condition. Okay, we have to select the region. So by this one is will be as select by clicking the shift key. Okay, then we have to rotate. Okay, then this one. Okay, all the things are created. Okay, okay, then done. So here it is. We have to check the global that will be encaster, because we have to apply the force, and we will see the effect of what we are giving, not the outward forces or any effect in the environment. So I am going to that all the displacements and all the effects, it should be zero. So I am clicking OK. Here you can see the boundary conditions that all the hardware is fixed. It is showing clearly, visibly. Okay. And now I'm going for the loads. Okay. Okay. Then I'm going for loads. Okay. So in the loads, I'm keeping the gravitational force. Okay. Then I'm going for the gravity. Here it is just force selected kind of step. The pressure, select cell, pipe pressure, body force. So many things are here. I am going to select the gravity. Okay. Okay. And here we have to see the in which direction we have to apply. Okay, then you can see that inflation will be in the z direction. Okay, z. Okay, so we have to apply the force in z. Okay, so here the component one is x-axis, component two is y-axis, component three is z-axis. So I am keeping the, the gravity according to my unit I have taken. So I am putting the 9.81. Okay, that is okay. Okay, then you will see the arrow of the z-axis. It's quite similar to that this one. Okay, now okay, next we have to apply the pressure force. Okay, for that we have to apply the surfaces. Okay, for that surfaces we have to apply the here. Okay, okay, because we have to apply the pressure on the inner surface of the top layer. So I am naming as inner surfaces. Okay, it is a geometry and continue. Okay, select the regions for the surfaces. Okay, for that we have to how we can put the pressure. So I am going for the tools, view code. We have to view the inner surfaces. So I am taking that y-axis. Okay, now let's see. It is the showing the inner surfaces. Okay, all of you can see that here it is just showing the inner surfaces. Okay, then I have to click the this one. Okay, okay, then done. Okay. Now I have to visualize that here it is the surface is created, that inner surface. Okay, you can see that we have to apply the force in that inner surfaces. Okay, Okay, then we have to go for the another forces, that is the pressure force. Okay, so I am going to create another force, that is the pressure, that is insert new step after the it is already existed initial step. Then we have to go for the gravitational, then we go for the pressure step. Okay, it is also static and general, it is continuous. Okay, here it is already coming on the nonlinear geometry.